The Spray Safely project focuses on the development of a pesticide application management toolset for worker protection standards. Pesticides are the categorization of compound chemicals, which consist of herbicides, insecticides, and fungicides. They are utilized for eradicating damaging pests within production agriculture. They are currently found to be the most cost-effective method for reducing yield loss within agricultural production. These pests consist of weeds, insects, and fungi. The disadvantages associated with the use of pesticides is the risk of pesticide exposure. If an individual experiences pesticide exposure, they are at risk of lifelong illnesses and even fatality. In 2009, in Nebraska, there was an average exposure of 54 individuals per year, which was 2 to 3 times higher than the national average. And in 2011, there was 34 reported cases of pesticide exposure, also higher than the national average. Due to the risks associated with the use of pesticides, the United States Environmental Protection Agency implemented a worker protection standards. This was structured and formulated in 1992 and was amended in 1995 and was most recently amended in 2015. The worker protection standards requires training of individuals who both handle products, apply the products, and enter fields where products have been applied. This requires documentation of pesticide use. This documentation includes the name of the pesticide applied, the active ingredient associated with that product, an EPA registration number, and an REI, which stands for Restricted Entry Interval. A restricted entry interval is the amount of time that must pass between the end of a product application and when a user can safely re-enter a field without the risk of pesticide exposure. Today's worker protection standards rely on a documentation procedure that is antiquated, redundant, and time inefficient. It utilizes a tabular format. It has to be accessible at a centralized location on the farm. However, that tabular format is usually turned in at the end of the day, at what point is then accessible. It is redundant due to the fact that with today's technology that has been implemented in precision agriculture, this information is being collected in a digital format within the field computers that are currently residing within equipment such as sprayers and tractors. Our system concept was to pull the information from the field computers in these tractors, upload it wirelessly to a cloud storage system, which is currently being done by equipment manufacturers. Our system would then pull the information from this cloud storage system, analyze and process it, and provide an output to our users, which are field scouts, producers, and farm workers. Where we would like the senior design team to pick up would be to implement a connection and an acquisition service from a product information service API, as well as build in some user functionalities such as user inputs and reporting functions. As I mentioned, this is not a ground up build and is currently the continuation of a master's project. The current project utilizes HTML5, CSS3, and Bootstrap for its formatting and web page structuring and styling. It utilizes JavaScript and jQuery for its functionality, and it utilizes Leaflet JavaScript for its geographic information system processes. It also utilizes Esri for its background aerial imagery. This front end is being hosted utilizing a Python Flask environment. The back end requires 3 databases, with the first database consisting of an application database. In this application database, there are 3 tables, which consist of an application entry, an instructor, and applicator information. It also requires a user database, which includes the user information, credentials, organization, and the farm and field information that pertains to the machine data acquisition. A third database has been designed, which is the product database, which consists of the product, the information pertaining to that product, an active ingredients table with the information pertaining for the active ingredients to a specific product, and the worker protections table, which consists of the information pertaining to a specific product. This information will be acquired from the product information acquisition service and stored in this database. The backend currently utilizes Flask Python environment for its processing and hosting services. It utilizes MySQL for its database management. It is all being hosted on a GoDaddy web hosting service, which utilizes a shared Linux operating system server with cPanel graphical user interface. Here is a screenshot of the current website that has been developed and will be continued to be developed upon by the senior design team. In addition to the previous screenshot, is a screenshot of the modals which are being utilized to prompt and accept information from the user. These are also being utilized to deliver information pertaining to a specific product application. We would like to see a senior design team continue development on our program by connecting the front-end user input to the back-end and enabling user input functionality, developing additional user input options, build in reporting features, integrate the product information acquisition service, which consists of connecting and acquiring information from the service API, as well as storing the acquired information to the backend databases. Additionally, we would like to explore the option of adding an iOS and Android application for this software program. We feel that this would be a great project for a senior design team to gain experience in not just web page development, but also acquiring information from a third-party acquisition service using their API, and utilize GIS processes to implement user functionality within the program for displaying an end deliverable.